Okay, let's try to solve this. The question says, draw the periodic table of the first 20 elements and fix the following elements in their correct groups and periods. Number 1 element there is beryllium. Number 4, atomic number 4. Number 2 is oxygen with atomic number 8. Number 3 is chlorine with atomic number 17. And number 4 is neon with atomic number 10. So, what you do is just to draw the miniature periodic table for the first 20 elements, which has only 4 periods and 8 groups. So you draw it. It has 4 periods and 8 groups. So what you are going to draw here is 5 horizontal columns. 1, 2, 3, 4, and 5 horizontal rows and 9 vertical columns. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Why 5 and 9? We are going to remove this one and use it to represent the groups and the periods. So this is a group. The whole of these are the groups. Let me represent it this way. The whole of these are the groups. And this is period. The whole of these are the periods. Okay. Now let's share the periods. This is going to be period 1. This is period 2, period 3, and period 4. So, and these ones, this is group 1, group 2, group 3, and group 4, group 5, group 6, group 7, and group 8. So the sharing is complete. The next is to fix these elements in these groups and periods, their respective position on the periodic table. How we do that is beryllium with atomic number 4. You write the electronic configuration is either by listing the electrons. You know that first period means first shell. The first shell of this beryllium, every first shell contains maximum of 2 electrons. So you write 2 there. Remaining 2, you put it on the second shell. So the last number you write represents the group. And the number of numbers you write represents the period. So it's period what? Period 2 numbers, that is period 2. And group 2, that is the last number, is group 2. Or you can write beryllium, the electronic configuration this way. 1s2, that is first shell or first period. S orbital of the first period, having 2 electrons. Now, after passing first period, next is 2s2, second period. S orbital of second period, having 2 electrons. So you focus on the last period too. So which means the period for beryllium is 2. And now the number of electrons on the s orbital of this last period is 2. So the group is 2. So beryllium belongs to group 2 and period 2. You go to group 2. This is group 2 and this is period 2. You write beryllium at the intersection. So beryllium represented in group 2 and period 2. The next is oxygen. Oxygen is number 8. And using the first method of writing electronic configuration, first shell always takes maximum of 2. Second shell takes maximum of 8, but we have registered 2 out of 8. Remaining 6, you write it at the second shell, which means the group, which is the last number here, is 6. Oxygen belongs to group 6. The period is how many numbers we have written. We have written 2 numbers, so it belongs to period 2 and group 6. We go to period 2 and group 6. That is where oxygen should be written with atomic number 8. The next is chlorine. Chlorine is number 17. Number 17. The first shell carries 2 electrons. Second shell carries maximum of 8. 8 plus 2 is 10. We have registered 10, remaining 7. So the last shell carries the 7, which means having 7 at the last means that chlorine belongs to group 7. Period is how many numbers we have written? 1, 2, 3. So it's period what? Period 3. So chlorine belongs to period 3 and group 7. So this is period 3. Group 7 is here. That is where we write chlorine. Atomic number 17. You can decide to write the electronic configuration of chlorine this way. 1s2, 2s2. We have registered 4. 2p6. We have registered 10 now. 3s2. We have registered 12. And 3p. 17 minus 12 is 5. So it remains 5 here. And you can see that chlorine has passed first period. It has passed second period. It's now in the third period. So it's still period 3. And on this period 3, the number of electrons on top are 2 plus 5. And that gives you group 7. Because 2 plus 5 is 7. So, having registered chlorine, we go next to neon. Neon is number 10. Number 10. And first electron picks 2, second picks 8, and that's all. So, having written the 8 as the last number, it means it belongs to group 8. Period 1, 2, two numbers, period 2. You can write neon electronic configuration using half-bound. 1s2, 2s2, 2p, 2p what? 2p, 6. No? Yeah, 6 plus 2 plus 2 is 10. It's complete. So it has passed period 1. It's now in period 2. Period 2. On that period 2, we have 2 plus 6, which is group 8. So period 2 and group 8 is where neon belongs. And that is here. Neon, atomic number 10. And this is the answer to the question.